So, hello future doctors. So, today again we start the PYQ session of 2016 year, that is the chemistry question papers. So, the first question is on your screen. Consider the molecules methane, ammonia and water. Which of the given statement is false? So, now we are moving to the solution part. So, again they ask you the false statement. So, when they ask you false, correct, incorrect, so first mark it. So, they ask you the false statement. Okay, what are the molecules they are given? One is methane, ammonia and water. So, first see what are the hybridization. So, how to calculate the hybridization? So, I am giving a simple trick here, and that trick is number of atom attached to that atom, means the atom whose hybridization we have to find out, that atom. So, number of atom attached to that atom plus lone pair present on that atom. Which atom? The atom which we have to find out the hybridization. So, this formula we are going to use to find the hybridization. Now, first let the take CH4. So, how many number of atom? 4. So, 4, and lone pair is there in carbon? No. So, 0 lone pair. So, it is 4. When it is 4, it is goes to sp3. In sp3, what is the bond angle? 109 degree 28 minute. So, this is the bond angle of sp3 hybridization. Now, let us count for ammonia, NH3, and how many lone pairs is there? 1 lone pair is there. So, what is the formula? How many atoms is there? 3, and how many lone pairs are there? 1. So, it is also 4 and it is also sp3, but the bond angle it's come as 107 degree. I will tell you why. Now, first let us count the water hybridization. So, in water oxygen having 2 lone pairs. So, now number of atom attached 2 plus 2 lone pairs, that is 4 sp3, but here again the bond length will coming as 104.9, like approximately 104 degree 9 minute. Now, if you see both all having the sp3 hybridization, but the bond angle will getting less. Now, what is the reason? Here 1 lone pair is there, here 2 lone pairs is there. So, when these 2 lone pairs are present, they are repulsion. So, lone pair repulsion is greater than lone pair bond pair repulsion. So, here more number of lone pair is there. When lone pair more number of lone pair is there, so it will more repel, and as a result the bond angle will get decreases. Here 1 lone pair is there, so as comparative to water, here that repulsion will be less. So, as a result the bond angle is again decreases from the 109 degree to 28 minute. So, now we see the statement whatever. So, the HCH bond angle in methane, the HNS bond angle in ammonia and water bond angle are greater than 90 degree. Yeah, that is a true statement. Now, second number, the HOH bond angle in water is larger than the HCH bond angle. Now, see, in water what is the bond angle you are getting? 104, but in methane, that is in CH4, whatever bond angle you are getting? 109 degree 28 minute, means methane bond angle will be larger, but here they are saying that water bond angle is larger. So, this is a false statement, and they ask about the false statement. So, option number 2 is the correct answer of your question number 46, and this question is asked from your chemical bonding chapter of class 11 NCERT. Now, if you see the third statement, the HOH bond angle in water is smaller than, yes, that is true, water bond angle is smaller than ammonia. Fourth statement, if you see HCH bond angle in methane is larger, yes, that is also true, that methane bond angle is the larger than ammonia. So, we have to see the false statement, that is option number 2, and it is the correct answer of question number 46. Now, we are moving to the next question, that is question number 47. So, question number 47 is on your screen. In the reaction, they given one reaction and they ask you what is X and what is Y. So, now we are moving to the solution part. Now, if you see, this is your alkyne part. and in alkyne this one and this one, these two are an acidic proton. So, what will happen? NaNH2 and liquid ammonia, so it will act as a base. So, what will happen? Base abstract this acidic proton. So, as a result, after removing this H plus, here C minus, that is the nucleophile will generate it, and this C minus will go and attack with this position and Br will be left it out. So, in X you are obtaining like H, C, triple bond C, CH2, CH3. Now, if I do the numbering here 1, 2, 3 and 4. So, if you see your X is nothing but this is your 1 butane. It is 1 butane. So, if you see among this option number 2 and option number 3, we can neglect it out, because X equal to 2 butane and X equal to 2 butane, which is not possible. Now, again this NaNH2 and liquid ammonia, it is act as a base, and this base abstract this proton. Okay. After leaving this proton as H plus, here C minus will be generated, and this C minus will go and attack with this position and Br will be left out. So, you are getting Y is equal to CH3, CH2, C, triple bond C, CH2 and your CH3. Okay, this one. So, if I do the numbering here 1, 2, 3, 4, 5 and 6. So, this is nothing but this is your 3-hexane. So, if you see among your option number 1 where it is given as 3-hexane, and in option number 4 it is given as 2-hexane, which is not possible. So, option number 1 is the correct answer of your question number 47. So, question number 48 is on your screen. Among the following, the correct order of acidity is. So, now we are moving to the solution part. So, if you see, these all are oxo acids and you have to find out the acidity order. So, always remember oxo acid, in oxo acids acidity is directly proportional to the oxidation state. So, always remember this thing. In oxo acid, if they ask you the acidity order, you have to first find out the oxidation state. So, let us see the oxidation state. First one is HClO3. So, how to find it out? 1 plus X plus 3 into minus 2, that is coming as n is equal to 0. So, it is coming as X minus 6 plus 1, that is minus 5 is equal to 0. So, X is coming as plus 5. So, if you see this one is plus 5. Now, again HClO4. So, this is for H, it is 1 for X, and again 4 into minus 2, that is minus 8 is equal to 0. So, X is equal to plus 7. So, this is coming as your plus 7. Now, if you see HClO2, so what is this? This is for 1 plus X minus 4 is equal to 0. So, X will come as plus 3. For HClO2, it is coming as plus 3. Now, for HClO, 1 plus X, that is minus 2 is equal to 0, and you are get as 1 minus 2, that is X is equal to 1 plus 1. So, here you are getting as plus 1. See again HClO3 3 6 6 minus 6 plus 1 minus 5 x is plus 5. For HClO4 4 into minus 2 that is 8, 1 minus 8 that is plus 7. For HClO2 minus 4 1 minus 4 is equal to minus 3 is getting a plus 3 and plus 1. So, now see plus 7 more acidic, then your plus 5, then your plus 3, then your plus 1. Now, just check where this plus 7 is for HClO4. In this option if you see HClO4, these two options we can neglect it out because this is plus 1 and this is also HClO3, it is coming as plus 5. So, this is not our option. Now, in option number 2 and 3 here also HClO4 is there, but if you see the lowest one is a plus 1 and plus 1 is given by HClO, but here it is given as HClO2. So, this is not our option. So, option number 2 where this is plus 1, this is HClO2, this is for plus 3, this is plus 5 and this is plus 7, and this is the correct option. Option number 2 is the correct answer of question number 48. So, this question is come from your redox chapter of class 11 NCERT. So, now we are moving to the next question, that is question number 49. So, question number 49 is on your screen. The rate of the first order reaction is 0.04 mole per liter per second at 10 second and 0.03 mole per liter per second at 20 seconds after initiation of the reactions. The half life period of the reaction is. So, this question is come from your chemical kinetic chapter of class 12 NCERT. So, now we are moving to the solution part. So, if you see here they are giving us, we know one term, that is R1 by R2 is nothing but C1 by C2, and what is C1? They are giving us 0.04 and C2 as 0.03. So, it is coming as 4 by 3. Now, we know that T half is equal to 0.693 by K, 0.693 by K, and if I am K, if I am taking on that side, so it will be as 0.693 by your T half. Now, if you see that K is equal to 2.303 by T2 minus T1 log of C1 by C2. Now, see up to here it is clear, I think, right. So, now I am going to rub this part. So, C1 by C2 is nothing but C1 by C2 is equal to 4 by 3, and T half we are obtaining here we are obtaining K is equal to 0.693 by T half. So, now replace this K with this, like 0.693 by T half is equal to 2.303, and what is T2? T2 is your 20 second, and what is your T1? That is your 10 second, and log of what is the ratio of C1 by C2? That is 4 by 3. Now, keep this T half on this side, and if you do the cross multiplication part, so it will be coming like, this is 0.693 into 10 by T half is 10, it is coming from this side. So, 2.303 log of 4 by 3. Now, if you do the cross multiplication here, you will find like 0.693 into 10 divided by 2.303 log of 4 by 3 and is equal to your T half. Now, if you solve this part, you will get your answer as answer number 1, that is 24.1 second. So, T half is equal to 24.1 second. So, how it will come if you solve this part? So, now option number 1 is the correct answer of question number 49. So, question number 50 is on your screen. So, which one of the following characteristics is associated with adsorption? So, basically this question is the, you can say it's come from thermodynamics as well as it's come from the surface chemistry. Okay. So, now we are moving to the solution part. So, this is a statement type question, and what they are asking, they ask about the absorption, and for absorption delta G, delta H and your delta S, that is Gibbs free energy, enthalpy and entropy, both all three should be negative value. So, if you see delta G is no, this is not, because all are delta G, delta H and delta S all are negative, all are negative. So, this is the correct option, that is option number 2 is the correct answer of question number 50. So, now we are moving to the next question, that is question number 51. So, question number 51 is on your screen. So, in which of the following options the order of arrangement does not agree with the variation of property indicate against it? So, now we are moving to the solution part. So, if you see, they are asked about does not agree. Okay. So, does not agree, we have to find it. So, if you see in this case, they are saying that increasing ionic size, yeah, that is true, because anions are in larger size. So, option 1 is the correct statement, that is the true statement. Now, if you see, this is the order increasing the first ionization enthalpy. Now, if you see boron, carbon, nitrogen and oxygen, the nitrogen is half filled orbital, and we know half filled orbital is more stable. So, as a result ionization energy, that is I am writing it here as IE, it will be more as compared to their neighboring atoms, means the order should be B carbon, then this is nitrogen and this is oxygen. So, this is the order it should follow, but they are not follow this order in this option number 2. So, option number 2 is the false statement and that does not agree the variation. Now, if you see option number 3, this they are giving us electron gain enthalpy. Again, in case of halogen, the electron gain enthalpy order should be fluorine, then your chlorine, then bromine and then iodine. And why this is actually the normal trend, we have to see like that fluorine, chlorine, bromine, iodine, because in case of halogen, if you go down the group, what will happen? The electron gain enthalpy will be decreases, but in this case that fluorine, they show the exceptional behavior because of its small size, and due to its small size the more repulsion will be take place, and due to this more repulsion the electron gain enthalpy will be lower than the chlorine, but here they are showing this is more. So, this order is also false order. So, option number 2 and option number 3, these two, option number 2 and option number 3, actually these two are the options for question number 51, because they ask you does not agree. So, these two are not agree. So, that is why option number 2 and option number 3 is the correct answer of question number 51. So, now we are moving to the next question, that is question number 52. So, question number 52 is on your screen. So, which of the following statement is false? So, now we are moving to the solution part. So, if you see this all statement like they are giving for the biological importance, that is the biological importance, of your S block element, okay, which is a class 11 NCERT chapter. Now, if you see among Mg2 plus and they ask about the false statement, okay, again you marked it because they ask you the false statement. Now, if you see magnesium 2 plus ions form a complex with ATP, that is correct option. Calcium 2 plus are important in blood clotting, that is also a true statement. Now, calcium 2 plus ions are not important in maintaining the regular breathing of the heart, that is the wrong concept. Okay, this is a false statement. So, this is the correct answer, that is option number 3 is the correct answer of your question number 52. So, these are the direct statements, they take it from your NCERT. If you go to the S block element, at the end you are getting the biological importance. In biological importance, these all statements are mentioned. So, option number 3 is the correct answer of your question number 52. So, now we are moving to the next question, that is question number 53. So, question number 53 is on your screen. So, which of the following statement about hydrogen is incorrect? So, now we are moving to the solution part. So, this question basically they asked about the hydrogen and that is the incorrect statement. So, first mark it incorrect, and this question is asked from the hydrogen chapter of your class 11 NCERT. Okay. So, now see the options. Hydrogen has a 3 isotope, of which no 3 isotopes will be there, but it is not that tritium is the most common. So, this is also a false statement, means incorrect statement. So, this may be your option, option number 1. Hydrogen never act as a cation in salts, that is also a true. Now, hydronium ion H3 plus exists freely in solution, that is also a true statement. Now, if you see the option number 4, dihydrogen does not act as a reducing agent, does not act as a reducing agent. So, this is not a correct option, they act as a reducing agent. So, this is a false statement. So, option number 1 and option number 4, that is option number 1 and option number 4 is the correct answer of your question number 53. So, question number 54 is on your screen. The correct statement regarding a carbonyl compound with a hydrogen atom on its alpha carbon is. So, now we are moving to the solution part. So, what they ask you, the carbonyl compound with hydrogen atom. So, let us draw one carbonyl compound with alpha hydrogen like this CH2R. So, they are having the alpha hydrogen. Okay. And what they do, first statement, a carbonyl compound with a hydrogen atom on its alpha carbon never equilibrium, no. So, if they are go tautomerization, like here tautomerization will taking place. So, what will happen in tautomerization? Here from here they will take this, they are having this lone pairs. So, what will happen, RCH I am writing like this, and here C double bond O, lone pairs will be there. So, here not tautomerization, this is similarly I am showing here, here CH2R. So, what will happen, these lone pairs will abstract this proton and this bond will be shifted on that side. So, what will happen, what you got, RCH minus C double bond O H and positive and CH2R. So, now what will happen, this bond pair will go on this side, here positive sign will be there, this negative and positive they forming a bond, that is RCH double bond C CH2R and here OH will be present. Now, if you see this one and this one, they undergo tautomerization. So, if you see the carbonyl compound with hydrogen atom on its alpha carbon never equilibrate with its corresponding enol. So, no, this is a false statement. So, they ask you the correct statement. Okay. So, option number 2, if you see, a carbonyl compound with hydrogen atom on its alpha carbon rapidly equilibrate with its corresponding enol, and this process is known as, no, that is not the aldehyde ketonic equilibrium, this process is known as tautomerization. So, option number 2 and option number 1 we can neglect it out. Now, if you see option number 3, a carbonyl compound with a hydrogen atom on its alpha carbon rapidly equilibrate, yeah, that is possible, rapidly equilibrate with its corresponding enol. So, this is the enol form and this is our keto form, and this process is known as carbonylation. No, not this process is not carbonylation. So, option number 3 also we can neglect it out. Now, see option number 4, which is the correct statement. A carbonyl compound with a hydrogen atom on its alpha carbon rapidly equilibrates, yes, rapidly equilibrates with its corresponding enol, that is the enol form, and this process is known as keto-enol tautomerization. So, this is the correct statement. So, option number 4 is the correct answer of your question number 54. So, now we are moving to the next question, that is question number 55. So, question number 55 is on your screen. My and NY3, two nearly insoluble salts, have the same Ksp values of 6.2 into 10 to the power minus 13 at room temperature. Which statements would be true in regard to My and NY3? So, again this is the Ksp concept, and Ksp is come from your equilibrium chapter of your class 11 NCERT. So, now we are moving to the solution part. So, if you see in the question they are given as My and it is dissociated as M plus and Y minus. So, let us take it here S mole per liter, this is S mole per liter. So, what is the Ksp for this? This is coming as S square, and what is the value of S? Root over Ksp. Now, if you solve this one Ksp, what is the value they are given here? Here they are given as 6.2 into 10 to the power minus 13. So, if you solve this one, it is approximately coming as 7.03 into 10 to the power minus 5. Sorry, 10 to the power minus, it will be 10 to the power minus 7. Yes. So, 10 to the power minus it is approximately. So, please calculate in your homes. Okay. So, just check it. It is maybe it is coming as 10 to the power minus 7. Now, NY3, if it is dissociated as, it is as N plus and 3Y minus. So, again the concentration of this is S mole per liter, here it should be a 3S mole per liter. So, what is the Ksp for this? It is coming as your S into 3S to the power cube. Do not forget to keep this power cube because of this 3. Okay, so, what is you are getting? You are getting a 27 S cube S4, and if you ask you what is the concentration of S here, so you will get 4 under root of Ksp by 27. Now, if you put the value of Ksp here, what is the value of Ksp? 6.2 into 10 to the power minus 13 divided by 27. So, if you do the multiplication here, you will get the answer approximately 3.8 10 to the minus 13 4. It is coming as 10 to the power minus 4. Okay. So, but please do it in your home by using calculators. Okay. Do not forget to this. So, but that is approximately it is coming as 3.8 into 10 to the power minus 4. So, now if you see, I am changing the color here. So, if you see the concentration of your NY3 will be greater than your S concentration of My. So, now we see what are the options they are given. So, please keep this one in mind. So, if you see the first statement, the molar solubility of My and NY3 are identical. No, this is not your correct option. So, they ask you the correct statement, right? What will be the true? See, mark it, true statement. So, this is not our true. The molar solubility of My in water is less than NY3. The salts of My and NY3 are more soluble in O. This is not the correct statement. The addition of salt of Ky so the solution of NY3 have no effect on this. So, no, this is also no. Now, if you see the option number 2, the molar solubility, because I already told about S of NY3 will be greater than S of My. So, if you see the molar solubility of My in water is less, My is water in less than that of Ny3. So, option number 2 is the correct statement of question number 55.